During the height of World War II, amidst the clash of steel and roar of vengeance, a different kind of weapon was being secretly developed. This wasn't a bigger bomb or a faster plane. It was something far stranger, a weapon that used the invisible power of sound. This is the story of the sonic cannon, a Nazi super-weapon project that aimed to turn vibrations into a deadly force. It's a tale that blurs the line between science fiction and historical fact, revealing the bizarre and often desperate innovations of a global conflict. What if you could incapacitate an enemy without firing a single bullet? What if a focused beam of sound could make soldiers dizzy, disoriented, or even worse? These were the questions driving a handful of scientists in the Third Reich. While we often hear about Germany's V rockets and jet fighters, their acoustic research remains one of the more obscure and fascinating chapters of World War II technology. These experiments were shrouded in secrecy, not just because they were military projects, but because they were pushing the boundaries of known physics. The researchers involved were venturing into uncharted territory, and the potential risks were as unknown as the potential rewards. The goal was to create a weapon that could project a powerful, low-frequency sound wave over a long distance, a so-called sonic cannon. At the heart of this research was a scientist named Dr. Richard Walaschik, working in Lofer, Austria. His team developed a device that looked like something straight out of a pulp sci-fi magazine. It consisted of two large parabolic reflectors, or dishes, with a central combustion chamber in the middle. The larger of these dishes measured over 3 meters in diameter. It was an imposing piece of machinery, a strange hybrid of a satellite dish and an industrial furnace. The name given to this peculiar invention was the Schallkanon, which literally translates to sound cannon. The science behind the sound cannon was surprisingly straightforward, at least in principle. The central chamber was designed to be a pulse jet engine of sorts. Methane gas would be pumped into the chamber and ignited in a rapid, controlled sequence of explosions. This would happen at a very specific frequency, around 44 Hz. Each combustion would create a powerful shockwave of sound. The sound waves would then be collected and focused by the massive parabolic reflectors. Just like a satellite dish focuses radio waves or a telescope mirror focuses light, the idea was to channel all that acoustic energy into a tight, directed beam, creating an invisible column of intense vibration that could be aimed at a target hundreds of meters away. It was, in essence, a way to weaponize a very, very loud noise. The intended effects of this sonic beam were graded by distance. At a range of over 200 meters, the intense low-frequency vibrations were expected to be deeply unsettling. The designers believed the sound would resonate with the human body, causing severe dizziness, disorientation, and intense pain. The goal was to induce a state of vertigo so extreme that soldiers would be unable to stand, let alone fight effectively. It was a form of non-lethal incapacitation, designed to neutralize enemy formations before they could even get within firing range. But the theoretical capabilities didn't stop there. At closer ranges, under 60 meters, the effects were predicted to be far more severe. The theory was that the focused vibrations would be so powerful that they could disrupt internal organs, cause massive internal bleeding, and be instantly fatal. The sound cannon was designed to be lethal at close quarters, a silent killer that left no visible wounds. The sheer intensity of the focused sound pressure was supposed to be enough to kill a person in under a minute. It was a truly terrifying concept, a weapon that attacked the very fabric of the human body. However, there's a huge gap between theory and practice, especially when you're dealing with experimental technology in the middle of a war. The sound cannon was tested, but these tests were extremely limited. The primary subjects were, unfortunately, animals. The results were inconclusive. While the device could certainly generate a powerful and deeply uncomfortable sound, its effectiveness as a weapon was questionable. The biggest problem was the sound wave itself. Sound dissipates rapidly over distance, and atmospheric conditions like wind, temperature, and humidity could scatter the beam, making it almost impossible to aim accurately. Another major issue was the sheer scale and impracticality of the device. It was enormous, heavy, and required a constant supply of methane gas. It was anything but mobile. Imagine trying to haul a 3-meter-wide dish and its associated fuel and power equipment onto a dynamic battlefield. It was slow to set up, vulnerable to attack, and its effective range was far shorter than that of conventional artillery, which could do a much better job of neutralizing targets from a much safer distance. Compared to a machine gun or a mortar, the sound cannon was a logistical nightmare. Ultimately, the German military leadership came to the same conclusion. In late 1944, the project was officially shelved. It was deemed too impractical and unreliable for field use. The war effort needed weapons that were proven, efficient, and could be mass-produced. The sound cannon was none of those things. It was a fascinating scientific curiosity, but as a weapon of war, it was a failure. When the Allies advanced into Germany and Austria at the end of the war, they captured the prototype and all the research documents associated with it. Allied scientists studied the device, but their analysis only confirmed the Germans' own findings. It was an interesting idea that simply didn't work in the real world. So, what is the legacy of this strange and failed super weapon? The sound cannon never saw combat, and its direct impact on the war was zero. But the research behind it was part of a larger, ongoing exploration of acoustics and its effects. It represents a fascinating, if dark, chapter in the history of science. A moment when the invisible force of sound was seriously considered as a weapon of mass destruction. Today, sound-based technologies are all around us, though thankfully, they're used for very different purposes. We use ultrasound for medical imaging, sonar for mapping the ocean floor, and even non-lethal acoustic devices for crowd control, known as LRADs or long-range acoustic devices. These modern systems are far more sophisticated, but they share a common ancestry with the crude, ambitious, and ultimately failed experiments of World War II. The story of the sound cannon is a powerful reminder that in the desperate race for technological superiority, sometimes the most imaginative ideas are the ones that lead to the strangest dead ends. It's a testament to human ingenuity, and also to its limits. Thanks for watching. If you found this dive into weird history interesting, be sure to like this video and subscribe to the channel for more stories about the forgotten corners of science and technology. We'll see you in the next one.